Good morning. Today we're looking at 2018 AP FRQ question number 4. It says it has a table to the left that gives us the molecular structure and the boiling points for the compounds CS2 and COS. They use a coloring scheme for black, gray, and white. I instead have used brown for the carbon, orange for the sulfurs, red for the oxygen. Okay. And it says the table to the left gives the molecular structures and boiling points for the compounds CS2 and COS. Question A, which is starred because it shows up on every AP test and almost always at the same answer or same concept, but so we're going to be very, very careful with it and make sure we talk about it explicitly. In terms of the types and relative strengths of all the intermolecular forces in each compound, explain why the boiling point of CS2 liquid is higher than that of COS. I forgot the word all, but it is a very important word in this. Okay, so when it says, whenever you get one of these questions when it's talking about IMFs and the such, the first thing you need to do is you need to list out your possible IMFs, or more accurately, list out all the IMFs for it. So let's start with the CS2. C S 2. All right. Now, in case you have forgotten, there are 5 possible types of IMFs. You could have an ion, dipole, dipole, dipole. There's hydrogen bonding, which I'm going to put a little star next to because it's a specific type of dipole-dipole. And then you have dispersion forces or London forces or London dispersion forces. Take your pick. If we look at the CS2, we go, okay, is it an ion? No. So if it's not an ion, it can't be ion-ion, it can't be ion-dipole. Is there a dipole moment? Is there a permanent dipole? Well, let's take a look at this. We have sulfur and carbon, which are different molecules. In general, I'm pretty sure the sulfur is more electronegative than the carbon. Even if it isn't, or even if it is, notice how these arrows are in the opposite directions. And because it's sulfur and carbon on both sides, this side will be the same as this side. Pull over from geometry. The hash marks let us know that they're the exact same length. Since these are exactly equal and opposite, this molecule ends up being nonpolar because there's no defined positive or negative side. So there's no dipole-dipole. We have no hydrogen, so there can't be any hydrogen bonding, which leaves us only dispersion, which everything has dispersion. If it has electrons, it has dispersion forces, always and forever. So for the CS2, the only IMF we have is dispersion. If we look at, however, the COS, which I'm going to draw over here, COS, and the double bonds. Okay. COS, we can go through the list again. This time I'm going to do that in brown. Now, again, there's no ions, so there's no ion-ion, no ion-dipole. Just for a quick review, how do I know there's no ions? Well, all of these elements, COS, CS, are in the top right corner of the periodic table, which is nonmetals. When two nonmetals bond, it is a non-ionic bond, or it's a covalent bond. Take your pick of phrasing. Covalent bond is strictly more accurate, but non-ionic is more relevant to this particular problem. So there can't be ion-ion, can't be ion-dipole. There's no hydrogen, so we can cross out that one already. But because of the difference in electronegativity, because oxygen is farther up and to the right, it's going to have a bigger pull on those electrons. And because this is going to be a bigger pull, a larger pull, we draw it as a bigger arrow, and these are not equal. So this side is going to be slightly negative, which gives us a permanent dipole to our molecule, or it is a polar molecule, which tells us that the COS has dipole-dipole and dispersion forces. So now that we've identified all the types of IMFs, we can talk about the boiling point. CS2 has a higher boiling point of 319 as opposed to COS, which is 223, almost a full 100 degrees of difference. Why? Well, if the boiling point is higher, then it has to be that the IMFs between the molecules of that element have to be stronger. But I hear you say CS2 only has dispersion. Well, it still has to be stronger than the dipole-dipole and dispersion of the COS. So a proper answer would be CS2 has only dispersion forces and COS has dipole-dipole and dispersion forces. However, the dispersion forces in CS2 must be larger than the combined dipole-dipole and dispersion forces of the COS. And there you go. Identify your forces and explanation. 1 point for identifying your IMFs, 1 point for the explanation. Done. B is a ideal gas law equation. It doesn't look like it, but let's break it down and see how we get there. A 10 gram, that's a number that's probably going to be important, sample of CS2 liquid is placed in a vacuum rigid, means it's not going to change, 5-liter container. The container is sealed and then heated to 325 K, at which point all the CS2 liquid is vaporized. Find the pressure. What is the pressure? Okay. I know this is an ideal gas problem via 3 things. Number 1, I have a solid container and a temperature and a pressure. I'm looking at a gas. So I'm looking at a gas. I have a volume and a temperature that aren't changing. If they were changing, I could be talking about Boyle's or Charles or the Gay-Lussac law, but that's not what's going on here. They're a fixed value. So fixed value, first indication that it's an ideal gas law. Second, the variables I have, volume, temperature, pressure, those are 3 out of the 4 variables of an ideal gas law. Finally, and this is kind of the most important, it's asking for what is the pressure. It's asking for a specific value, not a changing value, or what is the new one. And this is the first time pressure is mentioned. Again, it's kind of like the first point, but slightly different. So it says a 10 gram sample, however. If we think back to our ideal gas law, which is PV equals nRT, I always think of it as the pervert equation because it helps it stick in my brain, whatever works best for you. I have a pressure, I have a volume, I have the number of moles. Ooh, that's going to be a problem. I have R, which is a constant, and T. I don't have moles, I have grams. Thankfully, I know how to get between grams and moles. I have 10 grams CS2. How many moles is that? Well, if I go to my periodic table, I can go, okay, well, there's 2 sulfurs. Each of those have a mass of 32.06. I have 1 carbon, which has a mass of 12.01. 32.06 times 2 for the 2 sulfurs, plus 12.06 for the 1 carbon, gives me a total mass of 76.13 grams per 1 mole. And then I can find out how many moles I have, which, if I do the math, is 0.131 mole. Now I have moles, I have volume, I have temperature, I can find pressure. You can use any version of R. They didn't ask for a specific value or specific value for the pressure, but whatever one you pick, you have to carry your units all the way through. So I'm going to rearrange this. I'm going to move the V to the other side, get P equals nRT over V. And then I'm going to plug in my numbers. N is the 0.131 I already got. R is a constant. We will pick that in a second. I'm just going to finish plugging in my other numbers I have. 325. And V is 5.0. Now, if you go look at your equation sheet, there are several potential options for R. There is the 0.08206 liters atmospheres per mole Kelvin. That's one option. You could also use the 8.314 kilopascals per mole Kelvin. That actually isn't on the equation sheet, but it is under there as joules. It's more of the things that a lot of international chemists will use. If you answer in kilopascals, they are required to take it. Or alternatively, you can use the torr version, which is 62.36 liters torr moles Kelvin. Whatever one you pick, just make sure your answer is in that same value. I'm going to use the 0.08206 because it is what the AP scoring guidelines use, and more often than not, they'll answer in atmospheres. I personally do not agree with this, but I'm not on the committee writing the answers, so I'm stuck. But I should get 0.131 times 0.080 or 0.08206 times 325 divided by 5. Do all that math out, and you should get 0.7 atmospheres. This problem is worth 2 points. 1 point for getting the number of moles, and then the second point for solving for your atmospheres. Of particular note, this should be 0.70 atmospheres because it is a 5.0 liter container, which is your smallest number of sig figs. I forgot to write this here, which would mislead someone. And there we have it. Have a good day and good luck.